Welcome to this explainer where we're going to uncover one of life's most elegant and honestly most widespread design secrets. It's a principle so incredibly simple, yet it's responsible for a huge chunk of the biological world all around us. So, to get started, let's kick things off with a little puzzle. It's one that connects things that on the surface seem to have absolutely nothing in common, but you'll see they're secretly built from the exact same blueprint. Really think about that for a second. You've got the sharp, fresh smell of a pine forest, then you have a waxy steroid that's totally essential for our cell membranes, and then the stretchy, durable polymer from a rubber tree. What on earth could possibly be the link between those three? Well, it turns out they all share a secret molecular ancestor. All right, puzzle time is over. Let's solve this thing. The answer lies in a single, pretty humble molecule that nature uses with, frankly, astonishing creativity. And here it is, the 5-carbon isoprenoid unit. You really can think of this as nature's universal Lego brick. It's wild. From this one simple shape, life builds a staggering variety of complex and absolutely vital compounds. It's the ultimate example of modular design. Now, to actually use this Lego brick, nature activates it into two slightly different forms. You've got a starter piece that, you guessed it, always begins the chain, and then you have an extender piece that's used to add on and make the chain longer. This super simple starter-extender system, that's the key to the whole construction process. So how does life actually build with these bricks? This is where things really get going, clicking these fundamental pieces together to create longer and longer structures. Okay, so an enzyme called prenyltransferase acts like a master builder, linking these units together in what's called a head-to-tail fashion. One starter and one extender click together, and boom, you get a 10-carbon chain. Add another extender, now you've got a 15-carbon chain. Add another, you get 20, and it just keeps going. It's a beautifully simple linear assembly line. Now, what happens if this process just keeps on going? Like, it adds hundreds and hundreds of these 5-carbon bricks. Well, that's how you get the massive, flexible polymers that make up natural rubber. It's nothing more than an extremely long version of that same simple head-to-tail chain. But simple chains don't explain everything we talked about. How do they turn into those amazing, functional molecules we started with? The real artistry isn't just in making the chain. It's all about what happens next. This quote really gets to the heart of it because nature has a couple more tricks up its sleeve. First, it can change the way the chains themselves are connected, and second, it can fold them into these incredible three-dimensional shapes. Just look at this table. You can really see the genius of the system in action. Those simple head-to-tail chains, they give us terpenes, and the short ones are responsible for smells like pine and lemon. But check out what happens when nature uses a different connection. By joining two 15-carbon chains head-to-head, it creates a 30-carbon precursor for all steroids. Do the same thing with two 20-carbon chains, and you get the backbone for carotenoids, the pigments that make carrots orange. That one small change in how they're linked, it just opens up a whole new universe of chemistry. Let's zero in on cholesterol for a moment, because how it's made is just spectacular. It all starts with this molecule right here, squalene. As you can see, it's a long, floppy 30-carbon chain made by fusing two of those 15-carbon units together, head-to-head. And here comes the magic trick. This is one of the most dramatic events in all of biochemistry. An enzyme called a cyclase grabs this floppy squalene molecule, and in a single lightning-fast cascade reaction, it folds and zips it up into that rigid 4-ring structure you see. That becomes the core of every steroid, including cholesterol. It goes from a floppy chain to a rigid architecture in an instant. Amazing. So let's just step back for a second and appreciate the beautifully simple logic that nature is using here. It's a total masterclass in efficiency and creativity. So the key takeaway is really this. From a single building block, life uses just a few simple rules: how long to make the chain, which ends to connect, and then how to fold it, to create a breathtaking diversity of molecules. This modular approach isn't just clever, it's incredibly efficient. It allows life to innovate and adapt, creating new solutions from a trusted, universal parts kit. Realizing that things as different as rubber and cholesterol are basically cousins built from the exact same Lego brick, it really makes you wonder, right? What other profound unifying principles of life are hiding right under our noses, just waiting for us to discover them?